Hi all, welcome to another lecture of electrical machine design, the first module. So in this video we will discuss about the unbalanced magnetic pull happening in the machines. So normally in rotating machine, if the air gap around the armature periphery is non-uniform, then radial forces are developed in the rotor. Okay, there may be some conditions. It may be due to the manufacturing tolerance and any other irregularities, the air gap become non-uniform. Okay, so in that cases, a radial forces are developed in the rotor, and normally the direction of the radial force is perpendicular to the rotor axis. So this force or pull is called the unbalanced magnetic pull, or UMP. Short form is UMP. Okay, so we can consider a figure here. Okay, so these of the machine having poles. Okay, two poles, north and south poles. So the magnetic force between the two poles we have to find. So if one of the pole is moved by a distance dx, okay, movement means due to the irregularities in the air gap, we are considering it as it is moved by a distance of dx. Okay, dx, this is the small distance dx, it's moved. Okay, moved by dx, then the work done. Okay, then the work done will be equal to, how can we find the work done? Normally the work done will be force into the displacement. Okay, so we are considering that the F, okay, that is F is the force between two poles, and B is the flux density in their gap, and A is the area of each pole. Okay, and dx is the displacement moved by one pole. So the work done will be F into dx. Okay, and normally this work done will be equal to the change of energy stored in the magnetic field. Okay, the work done will be equal to, this is the magnetic field, the work done will be equal to change of energy stored in the magnetic field. Okay, so for finding the change in energy stored in magnetic field, the equation is energy density into change in volume. Okay, energy density into change in volume. So we get an equation like that. For energy density we can substitute half into b square by mu 0, and for changing volume we can substitute in it is equal to a into dx. Okay, this is the equation for energy density, half b square by mu 0. Actually that can be found by using our normal energy stored in inductor equation, that is energy stored is equal to half Li square. Instead of L we have to just substitute the value, that is mu 0 n square a by L, mu 0 n square a by L, and instead of I, okay, the equation for I we can be obtained from, that is H is equal to b by mu 0 equation, that is b is equal to mu 0 h v now. Okay, and also H is equal to, the equation for H is equal to, it is n I by L. Okay, so based on these equations we can substitute H, instead of I we can substitute b L by mu 0 n. Okay, so from these equations, from these all equations we are deriving this half b square by mu 0. Okay, I hope it's clear. And we get it as the change in energy stored in magnetic field as half b square by mu 0 into a into dx. So this change in energy is equal to the work done. So work done, equation for work done is F into dx. So F into dx equal to half into b square by mu 0 into dx. So from that we can find F is equal to half b square by mu 0. And from that we can find F is equal to 0.051 b square by mu 0 a kg. Okay, so this is the force equation. Okay, this is the force, that is the equation for the magnetic pull. Okay, unbalanced magnetic pull happening in the machines. So from this figure we can also understand what is UMP, what is the effects of UMP. Okay, so here this is the stator part and this is the rotor part. This one is the stator and this one is the rotor part. Okay, so we can see here that is the air gap length is different. Here the length of air gap is Lg1 and here the length of air gap is Lg2. That is on the top it is Lg1 and the bottom it is Lg2. Both are different. Okay, both are different. That is the air gap is not uniform here. Okay, so the air gap length Lg1 is greater than the length of air gap at the bottom Lg2. Okay, so this eccentricity may be caused by the manufacturing tolerances and the poor quality of machines, and sometimes it may be caused due to the wear of bearings. Okay, wear of bearings. So the force of attraction between top stator pole and rotor. Okay, that is top stator pole and rotor. This is the top stator pole north, this is the rotor pole south. Okay, so the force of attraction we are taking it as F1. Okay, this F1. So this F1 will be less than the force of attraction between bottom stator pole, that is south, and the rotor north. Okay, that is F2. So F1 is less than F2 because the air gap, okay, because the air gap Lg1 is greater than that of Lg2. Okay, so there is a difference in forces, okay, in these two sides. So hence a resultant radial force acts on the rotor in the downward direction, So this force or pull is called the unbalanced magnetic pull. Okay, so that is written here. Okay, that what I said is written here, so just go through that. So we will get a resultant radial force due to the similarities in the forces acting on top and bottom. Okay, this acts as a unbalanced magnetic pull, UMP. Okay, so next we are talking about some practical aspects of the UMP. That is, as we know, these practical aspects we have to consider must be taken into account while designing electrical machines. Okay, so the first point is the UMP is very large, especially in induction motors. Okay, so actually this is because even a small eccentricity can cause a fairly large unbalanced magnetic pull, as the length of air gap in induction motor is very small. Okay, in induction motor the length of air gap is very small, that is length in the less than 1 mm, like that. Okay, in the order of millimeters, like that. So hence a small eccentricity can cause a fairly large UMP. Okay, so every care must be taken to keep this air gap uniform around the rotor periphery. So in order to maintain the uniformity of the air gap in induction motor, the following aspects are incorporated in the design and manufacture. So the aspects we are considering here is the ball bearings are used. Okay, in most of the time we are using ball bearings, okay, so that a good alignment can be maintained over a long period. So the use of ball bearings prevents wear and also reduces the noise. Okay, and next one is the equalizer connections are connected in stator windings. Okay, so the stator winding of induction motors are designed with some parallel paths. Okay, parallel paths. So these parallel paths are connected to the equalizer connections. So these windings are so connected that they provide automatically a mitigating influence to overcome the effects of the unbalance. Okay, and the next point is it is designed such that they have a rigid shaft and a small length. Okay, so normally the induction motors are designed so that this type of induction motors are, that is most of the induction motors will have rigid shaft and a small length. Okay, and also they are provided with the bearings of bigger size. A stiff and short shaft gives negligible eccentricity. Okay, and therefore the UMP is small. Okay, that's the reason for that. And the next one is, next practical aspect is certain slot combinations of rotor and stator slots have a tendency to produce noise and vibrations. Okay, so the slots on both stator and rotor produce harmonic fields. Okay, that we know. So if two harmonic fields with actually we can say that if the number of slots, okay, if the number of poles differing by 2, okay, coexist in the air gap of an induction motor, they produce unbalanced magnetic pull and vibrations. Okay, and also symmetrical radial force of high frequency are produced by the superimposition of rotating magnetic fields due to different pole numbers. Okay, so this phenomena creates stator vibrations and magnetic noise. And the next thing we have to consider is there is considerable homopolar flux provided in two-pole machine due to asymmetry in the air gap. Okay, so normally the flux path is completed through shaft and frame. Okay, there is modulation of the air gap. Okay, there is modulation of the air gap length. Okay, air gap length, which induces an EMF in the bars of squirrel cage windings of induction motor. Okay, so this effect may be counteracted by use of parallel paths and equalizer connections in the stator windings. So these are the main practical aspects we are considering while designing a machine. You have to consider the practical aspects of UMP also. I hope you all understand what is UMP. So thank you.